Hi, you're here with Mr. Canada, and today we're looking at converting ordinary numbers to standard form. And this is where we have values greater than 1. Okay, so there's two cases we're going to do where we have very large numbers and where we have very small. So the first case we're looking at is very large, or just large. Okay, so the way we do this requires we know how many positions we're going to move the decimal point, or the decimal point changes, to get it into our standard form. Keeping in mind that really what's going on is that the numbers are moving, but physically when we're doing this on paper, we typically end up moving our decimal point. Okay, but just so you know that what's actually happening in the background. So very first thing is, for example 1, we're converting from 3900 and we want to put this in standard form. So we want to put a decimal between the first and second digit from the left. Well, our first and second digit, 3 is our first, 9 is our second, right? So that means I'm going to write 3.9, okay? Because that means that's our A value in our standard form, okay? But I'm going to do it back up here on our original example as well, because I'll show you in a sec why. Okay, so secondly, we want to count the amount of spaces between the numbers from the decimal to the end of the numbers on the right. So this just means between these two decimal points. So the original decimal point, it goes at the end of every whole number, and the one we moved it to. So when I count these spaces, I typically do loops. That's the way I learned it, and that's the way I actually still do it to this day. Pretty standard across most of the world, actually. So here, how much have we moved? Well, we've moved 1, 2, 3, right? So that 3, every time we're going to write this, sorry, that should be black. Every single time we write this times 10, and then this, however times we move, is 3. Okay, we put it up there. It's always going to be positive if n will be always bigger than 0 if original number, so our original value given, is greater than sorry, not x, is greater than 0. Sorry, not 0, greater than 1. Apologies. Okay. So basically, if you start off with something less than 1, it'll be negative. Bigger than 1, it'll be positive. Okay. So let's go through another example. That last part, step 3, just says what we kind of did up there. Okay. So step 1, this 3.9 times 10 to the power of, well, how many times we move? 3. So let's try this one. Okay. I'm just going to do it a little bit quicker. So first thing, put a decimal there, then put a decimal there. I know that I am going to then write 4.55. And notice I kept two numbers after the decimal point. Doesn't matter. The rest of them were 0, so I dropped the rest. So it's still writing it in a compact form. We know we're going to always write times 10, because the times 10 and to the power tells us how many times we move. So that's why it's always going to be times 10. That is not going to change and be times 8. It'll always be times 10. Now let's look. We go 1, 2, 3, 4, 5. And this number is greater than 1, so it stays positive 5. Last example, let's do 12. So we know we have a decimal point and the end of every whole number, right there, and we're moving it to right there. So 1.2 times by 10, and how many times we move? Well, just once. And that's, well, we know 10 to the 1 is just 10, so 1.2 times 10, well, we move the decimal place once, and we're done.